I am going to discuss few numericals based on the horizontal projectile motion. In the last session, I have discussed the theory of horizontal projectile motion, and in previous videos you can also visit the oblique projectile and with very good numericals. Let's start with today's session and hope you will enjoy my lecture. So the first numerical based on horizontal projectile is we have specific number of cars and the length of each car is 4 meter. Okay, there is a projectile which has some specific horizontal speed of 5 meter per second, which is projected horizontally from a height of 20 meter. So we have to decide to which car it will strike. So we have to decide to which car it will strike. So let's say this is number 1 car, number 2 car, number 3, number 4 and so on. So it will hit on first, second, third, fourth or fifth. Let's say, so firstly we will calculate the time taken by the projectile to reach the ground. So the very basic is time in horizontal is 2h upon g. So this is the time taken. Let's put the numerical values. 2 into 20 divided by 10, it comes out to be 2 seconds. So the time taken by the projectile to reach the cars is 2 seconds. Now in this time, what is the horizontal distance the projectile will cover? So the horizontal distance the projectile will cover is equals to the initial horizontal speed multiplied by the time taken, which is equals to 5 into time equals to 2. It comes out to be 10 meter. So the projectile will hit from the bottom of the building to the 10 meter. So the length of the first car is 4 meter, the length of the second car is again 4 meter, and here it comes near about something like here. This is 10 meter. So the projectile will surely hit the third car. This is our answer. Let's meet in the next numerical. We have numerical number 2 here. It's a very easy, very simple diagram. It's saying that a projectile is projected from a height h with initial speed v naught. Find v naught so that the horizontal distance is neta time h. Horizontal distance, this is the horizontal distance, is equals to neta time h. Then what should be the initial speed v naught? And the second question is also determine the speed of the wall when it reaches the ground. So with which speed it will strike the ground. To be very specific, we need to give the results in the given parameters like h and v naught. These are the two given parameters, so we need to give the answers in terms of h, v naught and neta. Let's start with the answers. So firstly we need to calculate find v so that the horizontal distance is neta times h. So to calculate the horizontal distance, we need to calculate firstly how much time it will take to reach the ground. So let's start with the solution. So time taken to reach the ground is very simple, which is equals to 2h upon g under root. So this is the time taken, and so the horizontal distance it will cover is equals to the initial horizontal speed multiplied by the time taken. This is the horizontal speed, but according to the question the horizontal distance should be equals to neta times h equals to v naught 2h upon g. In this equation we can calculate the value of v naught. So the value of v naught comes out to be neta h root of g upon 2h equals to v naught. We can take this h inside the root, it's become h square g divided by 2h. The 1h will cancel out, and so the value of v naught comes out to be neta hg upon 2. This is the result of v naught. This is the required results. So the second question is what's the speed of the ball when it reaches the ground, and to calculate the speed of the ball we need to calculate both the parameters, the horizontal component and the vertical component of the speed when it reaches the ground. So the vertical component, let's say Vy equals to Uy plus ay multiply the time taken. So initial speed along the y-axis is 0 because it is a horizontal projectile. So we will put here 0, and acceleration is minus g. Time equals to under root of 2h upon g. We can solve this. Minus equals to 2gh. This is the vertical component when it strikes the ground. The horizontal component remains same, which is equals to the initial velocity. So the initial velocity is v naught. This is a horizontal component. So the final speed, we can calculate the final speed. Final speed can be written something like this: vx square plus vy square. We can put the values. The x component is v naught square, and the y component is the square of this term. It comes out to be 2gh. 2gh. So it's quite easy now. Here the value of v naught. We need to calculate the value of v naught square. From this, v naught square comes out to be neta square hg upon 2. We will substitute this result, the result of this here, and we will get the answer. So these are the two questions. These are the part A and part B. It is quite easy just to analyze the diagram, what are the requirements, what are the given parameters, and how to tackle these situations. Let's see in the next important points. Here we have very important discussion regarding the horizontal projectile. We are given three projectiles A, B and C, which are at the same vertical height. Okay, so the question arises, what will happen when all the threes will be released simultaneously but under specific conditions? The ball A will release vertically downward, the ball B is released with some initial horizontal velocity, and the ball C also has some initial horizontal velocity, but the initial horizontal velocity of B and C are not same. Okay, obviously the initial horizontal velocity of ball C is slightly more as compared to the velocity of ball B. Okay, so this situation arises, what are the parameters which should remain same, what are the parameters which must be different. So regarding this is a very important concept, especially in assertion and reasoning or multiple choice question, what will happen in this scenario. So all the three balls projected simultaneously, but the ball A has no initial speed because it is just released from the height h. So its initial vertical component of velocity is 0. Obviously the vertical component of velocity of B and C also 0 because they are projected horizontally with some initial speeds. Okay, so all the three balls has 0 initial vertical component of velocities. Okay, so this one is the point. Second point is, as they are projected simultaneously in their specific directions from the same constant height, so they will travel the same distance, they will travel the same time. So the time taken by A to reach the ground is equals to the time taken by B and C to reach the ground. The reason is only one, because all the three balls are released from the same height and all the three balls has 0 initial vertical component of velocity. So we can say the time taken by these balls to reach the ground is same. Okay, C point. All the three balls will strike the ground with some different velocities, but they have constant, or we can say they have same vertical component of velocities. Here the vertical component of velocities of all the three balls, Vy, 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 they must be same because they are released from the same height, and all the three balls has zero initial vertical component of velocity. That's why there is no effect on the vertical component of velocities when it hits the ground. So the third important point says all the balls has same. Keep in mind it is the vertical component will remain the same. Has same vertical component. Vertical component of velocities when strikes the ground. When strikes the ground. Okay, but the total velocity, or we can say the total speed of the balls when this strikes the ground is totally different, because ball A has zero horizontal component when it strikes the ground. Ball B has different velocity component along the horizontal direction as compared to ball C. Ball B and ball C both have horizontal components but they have different magnitudes along the horizontal direction. Therefore, their final speeds, or we can say their final velocities when they strikes the ground is different, but only the vertical components will remain same. But their final speeds are different when they strikes the ground. When they strike the ground. Strike the ground. Okay. The last important point is it's written straight line. As all the three balls has a zero vertical component, initial speed or initial velocity zero component, that's why they will fall simultaneously. They will travel the same vertical displacement. They will cover the same vertical displacement simultaneously. That's why when the ball A analyze the ball B and C, the B and C will remain in the straight line as compared to ball A. Again I am saying they have initial vertical component 0. That's why according to ball A, the ball B and C will remain in the straight line when seen from ball A. So when A hit the ground, B and C also hit the ground. So according to A, if the person is at A, the person B and C should be in the straight line. Although if you are looking from the front, or if you are analyzing the complete projectile motion, the ball B and C has different trajectories. They have different trajectories, but along the y-axis, according to A, the ball B and C is in the straight line as seen from point A. So I am writing this. B and C always in straight line. In straight line as seen from A. Reason is very simple, because they have a zero initial vertical component of velocities. So this discussion is very important regarding the horizontal projectile motion. It will come in the session and reasoning or multiple choice question. I hope you will enjoy this concept. So here we have numerical number 3 based on the horizontal projectile. What it says, a number of bullets are fired in all possible directions with the same initial velocity u. Find the maximum area of ground covered by bullets. Okay, so according to this statement, the relevant diagram should be like this. It projectile is fired in all the directions. So let's say it is fired with some angle theta, and we need to calculate the maximum area it will cover. So to calculate the maximum area, the range will be maximum, and for the range to be maximum, the angle should be 45 degree. So theta should be equals to 45 degree. So this is the range in one particular direction, and same scenario can be analyzed in this direction. Then it is projected with 45 degree because it is projected in all possible directions. So in this direction, in all possible directions it is fired, and to get the maximum area, the angle should be 45 degree. So here the maximum area is like a circle. The maximum area is like a circle. This circle is the maximum area, where the radius of the circle is equals to the range maximum. Range maximum is the radius of the circle. So the maximum area of the circle is equal to pi r square, and for maximum the range should be maximum. Here pi, and the formula based of range is 2 u square sine of 45 cos of 45 upon g. We know the formula of the range, right? U square 2 sine theta cos theta upon g. Okay, so we can solve this. This is pi, or 2 pi u square upon g. Sorry, it's square pi r square. So this pi g square, 2 square equals to 4 u 4. This is sine 45 equals to 1 by root 2, and cos 45 again 1 by root 2. We can solve this. 4 pi upon g square u power 4, and this is 1 by 2 multiply 1 by 2. This 2 multiply 2 comes out to be 4, and 4 will cancel each other. So pi u power 4 upon g square is the maximum area covered by the bullets. This is our answer. Let's meet in the next numerical. So here we have a numerical number 4. It's something stair-like structure with based on the horizontal projectile. So the projectile is projected with some initial speed u in the horizontal direction. The stairs has particular height h and width b. So there are number of stairs. Let's say there are n number of stairs. The ball will hit the nth stair. It will something fall like this, and it hit the nth step. Okay. So for the nth step, the total height covered by the ball h equals to n times small h, and the total horizontal range r is equal to n times of b. Okay, so we need to calculate the value of n. So find the value of n. Find the value of n. Okay, again we will start with the equation along the y-axis. Here total height equals to u by t plus half a by t square. The total height is equal to n times small h, it is 0. The initial velocity along the y-axis is 0 minus half g t square. Okay, the acceleration along the y-axis is downward. Similarly, the displacement along the y-axis is also downward. So I am putting the negative sign here too. So this negative and this negative will cancel each other. So nh is equal to half g t square. So the value of t square can be written as something like this. We will use this equation. So this is the equation along the y-axis. Let's discuss about along the horizontal direction. Along the horizontal direction we have a range. A range is usually written as speed into time taken. This is the horizontal speed and the time taken. So let's put the value. The value of r is equal to n times b, and the value of t is under root of 2nh upon g. So from here we have utilized the y-axis, and this t is utilized here in the horizontal direction. So from this equation we will calculate the value of n. As both sides we have n, so we will remove this under root by squaring both sides. So squaring both sides, when we square both sides we will get n square b square is equals to u square 2nh upon g. This one. So 1 n will cancel. So here n equals to u square 2h upon gb square. This is our result. I hope you are enjoying this lecture. You are getting what is taught in this lecture. We will meet in the next video. Till then, just concentrate on your studies and subscribe my channel if you are new here. Wish you all the best. Bye bye.